Two employees sit in the same office. Both use the same AI tools. Both generate reports, analyze data, and write code with the help of automated systems. From the outside, their work may look similar, but an important difference is emerging. One of them simply uses the system. The other understands how the system is built, configured, and improved. As AI spreads across industries, this distinction may define a new divide in the economy, not between people who use AI and people who do not, but between those who shape AI systems and those who operate inside them. Consider how many companies rely on large AI platforms today. Marketing teams generate campaigns with AI. Law firms summarize documents using automated systems. Financial analysts rely on machine learning models to forecast trends. In each case, employees interact with systems designed by someone else. They receive outputs, adjust parameters, and apply results to their work. The tools increase productivity, but the core system often remains outside their control. At first glance, that difference may appear small. Yet it affects how much influence someone has over the technology. Inside organizations, two kinds of roles are gradually emerging. The first focuses on operating the system. An employee writes prompts, interprets results, and integrates the output into daily tasks. This work can be useful and productive, but the boundaries of the system are already defined. The employee works within those limits. The second role involves shaping the system itself. Someone decides how models are trained, which data they use, which metrics they optimize, and how they are integrated into workflows. Those choices influence thousands of future outputs. The difference is not simply technical skill, it is structural influence. This pattern is already visible in many industries. Technology companies that build AI models control the architecture of the systems. But influence also exists at smaller scales. Inside organizations, certain teams decide how internal data is used, how models are configured, and which automated decisions are allowed. The people making those choices shape how the technology behaves. Everyone else interacts with the results. A similar pattern appeared during earlier technological shifts. When the internet expanded, millions of people learned to use digital tools, but a smaller group built the platforms themselves. Website users depended on rules defined by platform designers. Search engines determined which information appeared first. Social media algorithms shaped which content people saw. The difference between operating a system and shaping it carried long-term influence. AI may produce a comparable dynamic. There is a reasonable counterargument. Some observers believe AI tools will democratize powerful capabilities. Modern systems allow people with limited technical backgrounds to analyze data, prototype software, and generate complex content. In many cases, these tools genuinely expand opportunity. Small businesses can now run marketing campaigns that once required large teams. Researchers can analyze large data sets without advanced programming skills. From this perspective, AI lowers barriers rather than creating new divisions. And in many situations, that is true. But democratization does not eliminate structural differences. It often shifts where those differences appear. When AI tools become widespread, the basic ability to use them may no longer create a strong advantage. If everyone can produce similar outputs using the same systems, the competitive gap moves elsewhere. It moves toward those who influence how the systems operate. Who defines the objectives? Who chooses the training data? Who sets the rules under which automated decisions occur? Those choices shape the environment in which everyone else works. This dynamic may produce second-order effects. Organizations that rely heavily on external AI platforms may gradually depend on systems they do not fully control. Algorithm updates can change how tasks are performed. Pricing changes can affect the cost of essential capabilities. Adjustments to models can influence workflows across entire teams. For many companies, these tools become core infrastructure, yet the infrastructure belongs to someone else. At the same time, internal expertise becomes more valuable. Employees who understand how AI systems function can adapt them to new conditions. They can modify workflows, adjust optimization goals, and design new applications. Their role goes beyond operating tools. They shape how those tools influence the organization. This difference may not always be visible in daily work, but over time it can affect strategic control. None of this means every worker must become an AI engineer. Most industries will still depend on diverse expertise. Domain knowledge, judgment, and communication remain essential. AI systems still require human interpretation and context, but as automation spreads, the ability to shape systems may become a distinct layer of influence. Some people interact with the technology, others define how it behaves. Understanding this distinction may become increasingly important, not because one role is inherently superior, but because the distribution of influence affects how organizations evolve. Technology rarely distributes power evenly. It often concentrates influence where systems are designed, configured, and controlled. As AI becomes embedded in everyday work, many people will benefit from its capabilities. Tasks become faster. Information becomes easier to analyze. New forms of creativity may emerge. But a deeper question remains. Who defines the structure of these systems? Because the people shaping the rules of AI often shape the environment in which everyone else operates. The next divide in the AI economy may not be between humans and machines. It may be between those who design the systems and those who simply work inside them.